Hello students, welcome to the statistics class. I am S. Nirmala, Assistant Professor of Statistics, and today's my topic is curve fitting by using principle of least square. And this is for the semester 3 students. Shall we start? Curve fitting. In semester 3, we are talking about the bivariate distribution functions. That means heights, weights together. We have seen if there is any relationship between heights and weights in correlation. Can we fit a regression? If the relationship is linear, we resort it to the correlation. If the relationship is not linear, if it is of curve type or it is quadratic or it's parabolic, so we have gone to the next method, regression method. Then now we will see if a bivariate data is given, then we are going to fit the straight line. How to fit we will see. Then second degree parabola, third one exponential curves, and fourth power curve. All this fitting we will do with the help of principle of least squares given by Lagrange's. Now, what do you mean by principle of least squares? Principle of least squares states that the sum of the squares of the deviations of the observation and its estimated value its estimated value should be minimum. That is, in other words, E is equal to summation I going from 1 to n yi minus a plus bxi should be The principle of least square states that the sum of the squares of the deviations of the observation and its estimated value should be minimum. That is, E is equal to errors, all the errors, sum of the squares of the errors, deviations or errors is one and the same. If all the errors, if we add up and square, it should be minimum. When it will be minimum? When dou E by dou A is equal to 0 and dou E by dou B should be equal to 0. So, this is the principle of least square given by the great Lagranges. We use this to fit the curves, different types of curves. As I said, we have seen fitting of straight line, fitting of second degree parabola, fitting of exponential curves. Exponential curves are of two types, and power curves. So all the 5 curves we are going to fit using the principle of least squares, which is given by the Lagranges, and it states that the principle of the least square states that the sum of the squares of the deviations of the observations and its estimated value should be minimum. That is, you add up all the errors, square them, and it should be minimum. So when it will be minimum? When dou E by dou A is equals to 0 and dou E by dou B equals to 0. If we do this partial differentiation is equals to 0, we are going to get two equations, one for this, one for this. We call those two equations to be as normal equations. By solving those normal equations, two equations, two unknowns, A and B are the unknowns. If we solve those two normal equations, we are going to get the values A and B. If you substitute those values in the first equation, whether it is a straight line, parabola, exponential curve or a power curve, the values of A and B we will get, and if we substitute those values, we are going to get the estimated value, which is minimum error. That means it is nearer to the given value. That is the principle of least square. We are going to use that in this chapter and solve our problem. So, first we will start with the fitting of straight line. Fitting of straight line. Yes. The linear equation of the form y is equals to a plus bx we have taken. This is nothing but every one of us know that this is equation of the straight line in which a and b are constant and y is dependent variable and x is independent variable. So there would not be any doubts in this. Now here, according to the principle of least square, we will apply principle of least square. According to the principle of least square, all the errors should be equal to summation over I going from 1 to n here yi minus, get this thing inside, a plus bxi whole square. This is equation 1 and this is equation 2. Now, we have taken equation of straight line y is equals to a plus bx, in which a and b are constant, y is dependent variable, x is independent variable. Now we are going to apply our least square method, wherein it says expectation error is equals to summation. You sum up all the differences, that is yi minus a plus bi whole square. You square it, sum it, and you are going to get equation number 2, which should be minimum. When it should be minimum? If we apply the partial differentiation on once a and on once b, we are going to get the values of a and b. So, dou of e is equals to dou of a 0 and dou of e by dou of b should be equals to 0, so that we get a and b values. Now, first we do this. Dou e by dou a is equals to, what is that? Dou e by dou a. Dou of e is summation I going from 1 to n yi minus a plus bxi whole square is equal to 0. That implies with respect to a, and only one term will be there, remaining all will go away. So, we will have summation I going from 1 to n yi minus a plus bxi, first square will come out, into minus 1 equals to 0. Therefore, we are left with summation, I take this side, this side. So, we are left with yi, I going from 1 to n, minus summation I going from 1 to n, a plus b summation I going from 1 to n, xi is equals to 0. So, this is what summation I going from 1 to n yi is equals to, there is no ith term here, so summation can be written as na plus b summation I going from 1 to n xi. Now this is equation number 3. So once we have taken partial differentiation with respect to A, we got an equation. Now with respect to B, we will take the partial differentiation. What are we going to get? Let us see. Now, dou E by dou B is equal to dou by dou B summation over I going from 1 to n yi minus a plus b xi square should be equal to 0. Should be equal to 0. Now what will that be equal to? This implies 2 summation over I going from 1 to n yi minus a minus b xi into minus xi equals to 3. That implies summation over I going from 1 to n xi yi is equal to a summation over I going from 1 to n xi plus b summation over I going from 1 to n xi square. So this would be your equation number 4. By solving equation 3 and 4 are known as normal equations. And solving these two normal equations for A and B, we are going to get the values. That A and B, if we substitute in our equation 1, we are going to get the value y cap A plus B of x cap. And this is the best fit for the given data. We are finding such a fit where that straight line is the best straight line. Where we get the best straight line? By using the Lagrange's least squares method, we are going to take sum of squares of the deviation and then do the partial derivation once over A and the second time over B, and solving these two equations, we are going to get the values for A and B. For that values of A and B, for that estimated values of A and B, our equation 1 will become the best fit. Now this is how we are going to fit the straight line using the principle of least squares given by the Lagranges. Now we will see how to fit the second degree parabola. fitting of second degree parabola. Now the second degree parabola is nothing but y is equals to e plus bx plus cx square. This is equation 1, where a, b and c are constants, y is dependent variable, x is independent variable. Now, the same procedure we have to apply the Lagrange's principle of least squares. According to the principle least squares, all the errors is equal to, error sum of squares is equal to, take the summation over I going from 1 to n, yi minus a plus bx plus cx square whole square, and take the differentiation over dou e by dou a is equal to 0, dou e by dou b is equal to 0, and dou e by dou c is equal to 0. First, take the error sum of squares, that is, you sum up all the errors and then square them. We are going to get equations for error sum of squares. Now, this error sum of squares should be minimum. How it will be minimum? We are going to take do the partial differentiation. Dou e by dou a is equal to 0, dou e by dou b equals to 0, and dou e by dou c is equal to 0. We have to solve and get these three equations. As I said, if we do these three equations, we are going to get the normal equations. By solving these normal equations, we can get the values for the constants a, b and c. If you substitute this a, b, c in equation 1, that would be the best estimator for the second degree parabola. To get the best estimator for the second degree parabola, we are going to solve for dou e by dou a equals to 0. Dou e by dou a equals to 0 means dou of dou a is what? Summation over I going from 1 to n yi minus a plus bxi plus cxi square whole square. So, if you do the differentiation with respect to a, we are going to get summation I going from 1 to n yi minus a minus bxi minus cxi square into 2 into minus 1 equals to 0. If you take away this here, we are left with summation I going from 1 to n yi is equal to summation a I going from 1 to n, then plus b summation I going from 1 to n xi plus c summation I going from 1 to n xi square. That will be equal to summation yi over I equal to Na, because there is no I term here, it is to be treated constant, plus b summation over I xi plus c summation over I xi square. This is called equation number 2. Now, dou E by dou B should be equal to 0. How do we do that? So, dou of dou B is equal to summation over I yi minus a plus b xi plus c xi square should be equal to 0. Now that would be, if I partially differentiate with respect to b, I am going to get summation over I yi minus a minus b xi minus c xi square into minus xi equals to 0. This implies summation over I yi equals to summation over I a plus b summation over xi plus c summation over xi square. Now that is so summation over I xi yi is equal to a summation xi plus b summation xi square plus c summation xi cube is the equation number 3. Now we have taken partial differentiation with respect to A and we got one equation. We have done partial differentiation with respect to B equal to 0. We have got another equation. Now we are going to do the third one, that is dou E by dou C equals to 0. So, dou E by dou C is summation I going from 1 to n yi minus a plus bxi plus cxi square whole square equals to 0. Now, with respect to C, if we do summation over I yi minus a minus bxi minus cxi square xi square equals to 0. Now, summation over I xi yi is equals to a summation xi square plus b summation xi cube plus c summation xi power 4. So, this is your equation number 4. Now solving So we have taken error sum of square as yi minus the whole yi whole square, and then we have done partial differentiation with respect to a, b and c. So we got 3 equations, this one and this, equation 2, 3, 4. Now these 2, 3, 4 are known as normal equations. On top we have 3 equations with 3 unknowns a, b, c. Now solving these 3 simultaneous equations, we are going to get the values for a, b and c. Now solving normal equations, we get a, b and c values. If you substitute these values in equation 1 and then this, we call it as the best fit or best estimate of the given second degree parabola. Hope you have understood full procedure. First, a linear equation is given, that is, in a case of straight line, it was y is equal to a plus bx, and in the case of second degree parabola, y is equals to a plus bx plus cx square. These are linear equations. If the equations are linear, then we are going to apply the principle of least square given by Lagrange's. What does the principle of least square say? You sum up all the errors and then square them. So that error sum of square we are going to differentiate with respect to, in the case of straight line, with respect to a and b, and in the case of parabola with respect to a, b and c. After solving, taking the partial differentiation, we are going to get 2 normal equations in the case of straight line, 3 normal equations in the case of second degree parabola. These simultaneous equations, if we solve, we get 2 constants for the straight line, a and b, and for second degree parabola we get 3 constants, a, b and c. Substitute them in their original equations, then those equations we call them as the best estimates of the given second degree parabola or given straight line. That best estimate will be the best fit for your equation. So this is what the principle of least square given by the Lagrange states, and we have seen for the linear cases. In the next class, I am going to tell you how to do if the equation is not linear. That means if a non-linear equation is given, how to find out the constants A, B, C, whatever it is. So how we are going to apply the principle of least square? If the equation given is not linear, then that I will tell you in your next class. For this, if you have any doubts, please do contact me. Thank you.